The purpose of this sub VI is to attach a header chunk to whatever inbound string we might happen to have. So that inbound string would correspond to all of the tracks in the MIDI file. I'll create my string in control and illustrate another control that we might need, such as the file type defaulting to 1. And let's just go ahead and do one more control. Number of tracks also defaulting to 1. In order to get those defaults to show up, simply type in the value that you want into the control and then go under Edit and select Make Current Values Default. Alright, we also need to change the representation of these controls. The type should be an unsigned 16-bit value. There it is, U16. And same thing for number of tracks. That should also be an unsigned 16-bit value. Alright, we've got our input controls set up. Let's give the result a place to go. Call that string out, and got an indicator placed now. So we've got our inputs and outputs all ready to go. The first important node that we can use is the concatenate strings. So our general idea is to build up a string. You can basically pull it down and expose as many or as few inputs as you might need. But our general purpose here is to build up a string which then can be tacked on, that is at the beginning of whatever track string we might have had coming in. So very first thing we would need would be the MTHD. That's our header chunk ID. Looks like I need to establish a few more connections first before we can actually run this VI. Whoop. Let's take a look at getting an output connected. There we go. So of course we see the string in is empty. We had essentially prepend the MTHD, and we see that as our string out. So let me give some arbitrary stuff for string in, say track stuff. Good, there we see MTHD is appearing before the stuff coming in on string in. So you'll notice that the order in which you attach to the inputs of the concatenate string node dictates, of course, the order in the resulting string. So we have so far established our header chunk ID. Now we need to do the number of bytes in the chunk. The header chunk always has exactly 6 bytes. So I'll create a constant with value 6. And here's the way we go from the numerical representation to a series of bytes in our string. This is called variant data type to flattened. And this converts any inbound value to the variant data type. So the pair of those two, when connected to a numerical value such as 6, will actually generate the appropriate 4 bytes for the way the number is supposed to be represented in the data file itself. Let me expose another input. And my track stuff is always supposed to go at the end, so that's why I'm moving that down one. Well, let's just try this and see what it looks like. So it's MTHD with some gobbledygook in between. To actually see that as a hexadecimal representation is pretty easy. Do a right click, select hex display, and now there's our MTHD, and there's our 4 bytes. There's 6 at the end. Hey, it's working out to be the 4 bytes that we actually need, so that's good. In order to ensure that you get the number of bytes that you expect, make sure that you set the representation correctly. So this is an unsigned 32-bit constant whose value is 6. Let me make another copy and attach that to our file type. Again, I need to bump down string in so it's always the last value to be concatenated. And if you look carefully, you can see where we've just wedged in another 2 bytes corresponding to our file type. If you look carefully at that area, sure enough, the value changes in response to our type setting.